should have this practice quiz open. It's in locked mode, so I wanted to just do that just so we can figure out if anybody's Chromebooks are going to give them issues. So everybody get into locked mode. Before you leave today, I'll make sure that I shut the lock mode off. So we're going to start off on the easier ones. Alright, every time you take a quiz, I'm going to have your name, class period, and no, you don't get points for those. But if you scroll down, there are sections, so that tells you that like this section is going to be factor label method and safe things. The whole worksheet is, but it starts off with the easy ones and it gets progressive and more down. Okay, the only way we're going to get really good at this is doing it a lot. Like if you're trying to become a really good runner, you're going to run a lot, right? We got to get some repetition. I know it's not the funnest part, but if you want to be good at it, this is what we got to do. So let's start with that first one, and I'm going to grab my notes so I can show you how I would expect this to look. And I will work it with you. So again, if this were your quiz, you would write at the top, quiz, this is a practice quiz, so I would write practice quiz, or if I said factor label method worksheet. Alright, so practice quiz, start your first one. You will get 1 point for writing your given quantity. Okay, that is a very easy point to get. Also, when you're writing, start at the top left, work over, and then down. Some kids write all over their paper. Like they'll start in the bottom right corner and then work up. Okay, so practice quiz. Factor label method. Label, butchering it. Okay, but over in the right corner, always write your name. Yep, thank you. And then your class period, always on the right corner, name, and then period 3 chem. Top right corner, guys. Oop, my goodness. I get neurological migraines, and I had one yesterday, and I'm kind of in the fog of it yet today. So things like stuttering and like I literally can forget my name sometimes. So if you see me like really struggling with words, that is why. Today's like the downward spiral of it, though. Yesterday was the worst. That's what happens when I don't get sleep. All right, we're gonna start with number 1 here, and it says 3.5 meters to centimeters. So we're always going to start by writing our given quantity. So that's what I've got here, 3.5 meters. And we're going to convert to centimeters. Now, I know you can probably do the slide rule. Section 1, you can do the slide rule. Every section after that, it doesn't work. Okay, so we're going to start with the ones we could do. The slide rule is a double check. So if you want to write at the top of your paper, King Henry died by drinking chocolate milk, if I were you, that's how I would do it. Okay, and do you guys remember the other units that we've learned? So remember, next to milli is micro, and then it was nano, pico. You don't have to memorize these, but you can have your notes out right now. On a quiz, you normally can't, but right now this is just homework, just practice. Okay, and then next to kilo is going to be these guys. So this worksheet uses some of these. On a quiz, I won't use one of those, or a test, okay? I just want on homework you to be able to recognize them. And there are a few on this worksheet where they're the blue ones, so technically purple, but it's blue to you. All right, so our very first conversion factor has to go from meters to centimeters. Now, if you know the relationship between those two things, it is a single step problem. Okay, so if I know that in 1 meter there are 100 centimeters, which hopefully we do, I can do it in 1 conversion factor. I did not give myself enough room. Because I started with meters, I have to have meters on bottom. So in 1 meter, there are 100 centimeters. Meters on top, meters on bottom. I'm in the unit I wanted to get to. So that's our last step. So you're going to take 3.5 times 100, which means you move the decimal place 2 places to the right, and I get the number 350. But now we have to process 2 things. I want every one of these in scientific notation for practice, and we're going to round it to the correct number of sig figs. How many do I have in my given quantity? 2. So this is already in 2, but let's do it in scientific notation. 3.5, And I'm going to move the decimal 1, 2 times to get here, which is scientific notation every single time. So times 10 to the second. And my unit then is centimeters. Now when you type this in, I want to show you on my answer key here how I want to see it. I think it'll let me pull the answer key. So this is the one I want to see. Okay, I will always type the base unit, asterisk, 10, shift 6, which is your caret key, 2, space, unit. The unit has an exact correct annotation. Centimeters is lowercase c, lowercase m. No decimal if you need to. Like some people want to write it MIN for minutes and then a dot. Just no decimal, it's just MIN. If it were a test or a quiz and you just wrote that with a space or something off, I'll go back and correct it. But I do this consistently, so if you do, then you'll see really quickly. Like when this spits back at you, it'll give you actual correct answers. I always put a space between my number and my unit, just so there's no confusion. Like sometimes they look similar. All right, go ahead and try the next one. Also, I've been recording. I'm recording currently, and I'm putting them on my website. That way, you guys can go back and watch it again if you would like to. They can't hear you, like they might hear someone's talking, but they can't hear what you're actually saying. So on my class website, I have solutions to the last few worksheets too. Oh, also, win this week is going to be us doing factor label method with correct number, sig figs, and scientific notation to get extra practice. So if you're still struggling after tomorrow, come to win tomorrow. Anybody's welcome. One of the last questions in this form is, are you coming to win? So hopefully we can finish it by tomorrow. In my notebook, I added this little resource because this is what I show you like 1,000 times, and we will talk about it again. Yeah. You can actually take a picture of the real thing. That might be your best picture. But if you missed that day, or if you want it, you can definitely have an image of this. I've tried to upload it like several times, and the Wi-Fi just doesn't like me. But we got deci and deca. Remember, technically a decimeter, for instance, is 1/10 of a meter. I'll move my arm for you. And a decameter is 10 meters. Okay, just a reminder, that's what those mean. So when we're talking about a decimeter, we can say there's 10 decimeters in 1 meter. But here it'd be 10 meters in a decameter. Process that. 10 meters for a decameter, but 10 decimeters in 1 meter. Okay, I'm going to show you the example. I know. That's what we gotta think about for this guy. So what has to be on the bottom for our first conversion factor? Kilograms, because we started with it, we know there's gotta be kilograms. Now I don't expect you to know how many decagrams are in a kilogram, so let's just go to the base unit and then jump over. It's the easiest way to not have to overthink it. So we know in 1 kilogram how many grams are there? 1,000, right? Right? A kilo is 1,000. So up here it's like 10 to the 0, 10 to the 1. Oh, King Henry died by, oh, I moved it wrong. Sorry, this is 10 to the 1, 10 to the 2, 10 to the 3rd. Meaning 10 to the 3rd is 1,000. There's 1,000 meters in a kilometer. There's 1,000 grams in a kilogram. All right, so we got that one. Now our kilograms crossed off and we're in grams, but we want to get to decagrams. So we're here and we want to get there. So we know, remember you always move to the left one, but because in reality what that means is there are 10 grams in a decagram. Okay, those are the big guys. It's a big letter, 10 of them. So in 1 decagram there are 10 grams. Now my grams cross off and I'm in decagrams, which is where I wanted to be. So mathematically, I'm going to take 10 times 1,000. So I get 10,000. Dividing by 1 doesn't change it. Times 1 doesn't change it. If I take 10,000 and divide it by 10, I get 1,000 decagrams. How many sig figs are in my given quantity? 2. So I'm going to put that number in scientific notation with 2 sig figs. Okay, I'm going to do scientific notation first, and then I'm going to do it in 2 sig figs, because we go 1, 2, 3 places over. So it's technically 1 times 10 to the third, but is that 2 sig figs? No, so I have to go 1.0 times 10 to the third decagrams. Circular box, your final answer. Okay, I'm going to try, go slow as I can so I can give you processing time. I hate listening to myself on videos, but I have noticed how fast I talk, and I'm trying to talk slower. It's really hard for me. Alright, double checks. Is this a true statement? Is this a true statement? Did everything cross off? Is this what you're left in? Do you have the correct number of sig figs? And did you end up in the unit you were trying to get to? Yes?
So the like 1,000 grams in a kilogram, that's just like that just kind of feeling like
1,000 grams in 1 kilogram, yes. The ones I expect you to know are the purple ones. King Henry died by drinking chocolate milk. Now guys, remember, when you move to the left with the slide rule, you were taking it times 10. When you move to the right with the slide rule, you're dividing it by 10. So let's look at this with the slide rule. So if you're going from kilograms, I'm going to grab a different color so you can see better. If I'm going from kilograms, it would go 1, 2 to the right, right? If I started with 10 and I went 1, 2 to the right, I end up with 1,000. Okay, I know that's way easier. I really do get it. If it were something as simple as this, I am fine with you doing that when we're not doing factor label method. Okay, but right now we're learning this in a way that we can double check in our heads with a way that we know really easy. Because we're going to get to problems where you can't do this. Okay? Anytime you're not in the metric system, you can't do this. You cannot. Slide rule only works with base 10. Alright. Go on and try the next one. Remember with syntax, it's 1.0 asterisk 10 shift 6 for the caret key 3 space capital D lowercase g. Why does it need to be a capital D? Because a lowercase d is deci, remember, okay? So to get a decagram, you need the capital D. Remember, 1 point for your given quantity. For number 3, we're just going to start by writing 20.0 milliliters. Okay, record it with the correct number of sig figs and your unit. That would be 1 point on a test or quiz. Now the next point is having the correct stuff in this conversion factor, and then I give you 1 point for putting them in the right spot. So say, or depending on the quantity of the quiz, like if it's a quiz, sometimes it's half and half for a full point. If it's a test, sometimes it's 1-1. But basically half your points from getting the right stuff in here, and the other half is from putting them in the right spot. So we know we need milliliters on bottom. And if we want to go to liters, you're going to think, do I know how many milliliters are in a liter? Yes, a milliliter is 1,000th of a liter. If it's 1,000th of a liter, 10 to the negative third, how many milliliters are in a liter? It's just the same as millimeters if you need to think about a meter stick. How many tiny little millimeters are in a meter stick? It goes 10, 100, 1,000. There are 1,000 milliliters in a liter. Anything with a milli in front of it, you're going to have 1,000 of them for the base. Thank you. So my milliliters crossed off, and I'm in liters. Mathematically, 20 times 1, still 20, divided by 1,000, 0.02, with 3 sig figs. Now concept check, if I went from something that's really small to a bigger unit, it should make sense that my number got smaller. You could also do the slide rule to check. But we're going to put this in scientific notation. So we got to go 2 to the right, 2.00 times 10 to the negative second liters. Again, one common mistake kids have is they don't see their decimals. So make your decimals nice and dark so you can see it. Or they go type in their calculator and they don't type the decimal and they'll type just like 200 instead of typing the 2 point. Alright, number 4 is pretty similar, so when you get that typed in, go ahead and try number 4 and then I'll jump in and help. Oh, I started writing the same thing. I want to show you some math magic on this one, but I'm going to give you a chance to do it first, and then I'll show you. Ready for the math magic? Okay, let's look at kilograms and grams on that table that we did. So we know a kilogram is 10 to the third grams, right? There's 1,000 grams in a kilogram, so 10 to the third. So one thing you could do is we can say in 1 kilogram, I have 10 to the third grams instead of writing 1,000, because in math, if you were taking something with an exponent times that, so let's just say we were straight up taking 10 to the negative 4 times 10 to the third, what do you actually do with those exponents? You add them. So if you're multiplying, you add the exponents. If you're dividing, you subtract them. So negative 4 plus 3 gives us 10 to the negative 1. So what you're actually going to get is 3.9 times 10 to the negative 1 grams. It's a lot easier, especially when we start doing micro and nano and giga and more than one operation. I would prefer it this way, yeah, because you didn't even have to write all those zeros. If you can just throw it down in scientific notation right away and zip it out, it's so much easier. You can even do it in your head. Obviously, you wouldn't even need to write this. Okay, if you wrote that and that came out, that's fine. We'll do another example. So go ahead and try number 5. See if you can do it that way. If you want to have that table out right now so you can use that, right? We're still in the practicing stage, but it'll give you an idea of what you need to practice too. So because these both have prefixes, I prefer to go to the base and then go, because I think it's just the easiest method to show you guys. So I will go from deciliters to liters, then from liters to deciliters. Nope. The final answer should be yes. Okay, so we're in deciliters. So it's a tenth of a liter. So your thing will say 10 to the negative 1. So what that means is 1 deciliter is equal to 10 to the negative 1 liters. These are all the fraction of a liter that it is. So you can say for a deciliter that 1 liter is equal to 10 to the first deciliters, right? There's 10 deciliters in 1 liter. Or you can say that 1 deciliter is equal to 10 to the negative first liters. Both are true statements. Take a second to process what that means. Is because 1 liter is 10 of these, and 1 deciliter is a tenth of a liter. Either one of them work, but I think this is the one that you're going to tend to use because it's on your table, right? The negative 1. Are we processing how that makes sense? Both of them are true. All right, so why does it have the negative 1? So what this is saying is that 1 deciliter is equal to a tenth of a liter, right? So a liter divided into 10 little pieces is a deciliter. It's just a really small piece of it, yep. And then this is 1 liter is actually equal to 10 of these little guys. Alright, I know we all come in very, very different math skills, so if that is really hard for you, just don't even do it, okay? But if this is something that's easy for you, it'll be a shortcut. Alright, so what we were saying then, I think what we're going to tend to do is the 10 to the negative 1 liters is 1 deciliter, right? Because when we look at our table, that's what it was. Okay, and then we know to go from liters to deciliters, I know there's 10 to the first liters in 1 deciliter. I will. I'll do the other one too. So it'd be 1 minus 1, so 0, minus 1, so it's negative 1. And that is the final answer. I'll go ahead and show you the other method as well. So if we were going to do it like normal. So if scientific notation is still something we're practicing and learning and we're not experts on yet, we can stay in standard notation. So it gave it to you as 25 deciliters. So when you looked at your table, you should have known that a deciliter is 1/10 of a liter. So there are 10 deciliters in 1 liter. This pen is taking a break, so we're going to put the 10 deciliters on bottom. Now to go from liters to deciliters, I know that a deciliter is actually 10 liters. So I want 10 liters on bottom and 1 deciliter on top. So my liters cross off, my deciliters cross off. I'm left in deciliters. Mathematically, you'll take 25 divided by 10, and I get 0.25 deciliters. Now, because I have 2 sig figs, putting that into scientific notation means I'm going to move the decimal 1 place to the right. So I get 2.5 times 10 to the negative first deciliters. Either option is fine. And then you could always go back and double check with the slide rule. If I'm starting with deci and I go 1, 2 to the left, I went 1, 2 to the left to get 0.25. Again, that method isn't always going to work. Just for metric system. All right, go ahead and try number 6 with whichever method works for you. I will work out both again and show you so you can look whichever one you want to look at. Okay, try number 6. I got off on my numbers. Did I jump? Oh, no. I forget that my paper's numbered weird. Okay. If you have questions, I can answer them too, guys, and you're more than welcome to talk to the person next to you too. This isn't an actual quiz. It's just wanted you to see how the format will be, so when you do a quiz, you've got experience with it.
So is this
My thought was to give accuracy points, but like I'm giving you all the answers so far, so I might give you accuracy points, but we'll see. We'll see how the ending goes. Right now, you guys are needing more help than I thought you would, if I'm being truthfully honest, so it might just end up being completion points. But that's why I did it. I wanted to see where you all were at. And honestly, if like metric system's hard and scientific notation's hard, that makes all these other things a little harder to learn too. So there are only actually 21 problems, and we are currently on number 7, I believe. We're on 6. We're on number 6. We won't get through all of it today, but I want to at least get through part 1 today, which only has 8 questions, or 7 questions. So we only have 2 left. Hopefully by tomorrow we'll be more independent, but we'll see. The first section. So which means you have 2 problems left. This one and 1 more. Yeah, I don't like writing all these zeros. I'll do the one you guys that are afraid of scientific notation do first. 1, 2, 3. Once you get good at scientific notation, the other method is easier, I swear. I'm so dyslexic, I throw zeros and... Will I ever what? Can you say that again? Like going to other units? Yeah, like part 1 is just metric to metric, part 2 is metric to customary, and then part 3 is like problem solving using this. So like I get increasingly more challenging. The bright side to the other sections, guys, is I feel like right now the metric system is confusing you, weirdly enough. So I feel like once we get out of the metric system, maybe it'll be magically easier. I don't know. I'm hoping. Magic sauce, right? All right. TBD. I'm contemplating giving you a metric system thing because your metric system skills are lower than previous years. I'm not sure where that came from, but much lower than normal. So, well, I want you to get good at it. I think it'll naturally happen too. Like with experience throughout the year, we do it so much. But, so maybe I'll give you a metric table or have you write it out right off the bat, something. Because I don't want that to be what I'm assessing you on when I'm looking for factor label method. So, TBD. I'm hoping we get better, but we'll see. Usually it's something you have repetition every single year. I feel like you guys didn't have it as much as years past have. Okay. So we had to divide by 1,000. All right. See how many zeros there are now? Did I give it enough? 1, 2, 3, 4, 5, 6 zeros, right? So when we write this in scientific notation, we should write 5.00. We need 3 sig figs times 10 to the negative 7th kiloliters. Is there anybody that prefers the other method right now? The exponential? Yeah. Not many. Ignore me if you're not that person, okay? Go ahead and do the next one. If you are, I'm going to write it right now in that method. 1, 2, 3, 4. See how many less zeros I had to write? I mean, ignore me, but like admire it at the same time. It's so much easier for my dyslexic brain. Because you just had to take -4 minus 3. Boom. If scientific notation isn't hard for you, it would be. Yeah. Okay, maybe it's having physical science with me. I'm just going to pat my own ego right now. I'm just kidding. All right, number 7. See, I really want to do it for number 7. Ugh. Too many. All right, I'll do it your way first, then I'll do it my way. 1, 2, 3. Instead of commas, guys, put spaces. Commas are going to confuse you with decimal points. Don't put commas. You'll, at some point throughout the year, mistake a comma for a decimal point. That U means micro. I couldn't find the micro symbol, and I got lazy and did a U. So micro, it's just a hook in front of it. And we're going to go to millimeters. So remember, micro is times 10 to the negative 9th of a meter. So that's what we should know about. Oh, sorry, -6. I did the wrong one. -6, not -9. Nano is -9. All right, but I will write it like you like to see it. That means that there are 1, 2, 3. Oh, 2. No, I should have had that on bottom. 1, 2, 3. I again think the easiest method for you guys will be to go to the base unit and then jump to the millimeters. Okay, so a micrometer is a millionth of a meter, so there are 1,000,000 micrometers in 1 meter. And then we know if we're going to a millimeter, that in 1 meter we are going to have, so meters crossing off, a milli is 1,000th. We are going to have 1,000 millimeters. So, why what? Okay, so what I was doing in my head here is if you're dividing by 1,000,000, it's how many zeros that you have is how many places you move it. Since I have 6 zeros, I'm going to go dividing means to the left. 1, 2, 3, 4, 5, 6. Okay, and then I'm going to multiply by 1,000, so there's 3 zeros, so I'm going to go to the right 3 times. 1, 2, 3. That's what I was showing. In my head, I was doing the math. Type it in a calculator if you want to. So anytime you're dividing by something base 10, you divide by how many zeros there are. And then if you multiply base 10, it's times how many zeros there are. So if there are 3 zeros, I move to the right 3. If there are 6 zeros, I move to the left 3. That's how the slide rule works, but I don't think you've ever processed it mathematically. It's just a pity. You just scoop down the ladder, just magically doing stuff. No, it's actually math you're doing, because it's a base 10. I think usually freshman year, that's a good transition out of the slide rule, is processing what it does for you math-wise. It's not magic. It's not magic. Okay, I'm going to do the other way. But that way's there for you, okay? Let's put in scientific notation. Sorry, 8. And how many sig figs did I have in my given? Just 1. So times 10 to the 3, 4, 5, 5th. Now, if I had done it the long way, the other way, ignore me if you don't want to do this and go on to the next one.
Why couldn't we go from the micrometers to why do we gotta go to the base and then back?
I find it's easier rather than having kids try to figure out how many millimeters are in a micrometer. If you can process how many millimeters in a micrometer, that's fine. You can do that. But sometimes it's hard, especially when you're doing that 1,000 jump rather than the 10. People start to panic. So I try to make the simple. Will it save? It should save. Yep. Here, before you guys close, I'll do it after you close. I want to shut down locked mode. That way you can just get it and have other tabs open. I just wanted to make sure all your computers worked in locked mode. Okay, so for this one, it's 10 to the 6th micrometers in 1 meter. In 1 meter, there's 10 to the 3rd millimeters. Minus 6, so 2. Okay, so you only have one more that you need to do, right? Oh no, that was the last one. If you would like to try the next section and see how it goes when you have time to process at your own rate, that is a good idea. We will be doing it tomorrow. So if you want to give it a shot, especially if it's something that's hard for you guys, I do encourage you. The next one, you do need to remember that in 1 inch, how many centimeters do we have? 2.54. And in 1 mile, how many feet? 5,280. There you go. If you want in your notebook, like how I have that table, I would recommend starting your resources, throwing them together. Like I like to know common fractions, so I added that to mine. I have my metric system, but you could also add those I was just talking about. That in 1 mile, 5,280 feet. Yeah. Alright, if anybody wants to take a picture of this, you're more than welcome to, but it's probably easier to get a picture of that than there is the. I've tried to upload it to the drive. Guys, this is the worksheet here. This is for you to make sure.
Actually really good at this stuff.
It might be Sam.
Yeah, because it's like the base stuff that they use like all year.
Wrong, I think. Go ahead.
I have to flush, can you?